Okay, now after virtual network and inter-site connectivity, it's the time to focus on network traffic. And in this module, we're going to focus on load balancing options associated with the different network traffic controlling configurations available on Microsoft Azure Cloud. We'll start with introduction to Azure load balancers, and then we'll talk about application gateway. And then after that, we're going to talk about network watcher. Let me tell you one thing, guys. This is that particular module in which there are so many guys who always have confusion because there are multiple options which are available for load balancing, as well as there are people who get confused between what is the difference between load balancer and application gateway and some other options which are providing similar kind of facilities. Also, we are going to talk about network watcher service after that. At the end of this, we always have a module which is going to be a lab associated with that. So we have a lab associated with this module also, in which we are going to focus on implementing traffic management with the step-by-step configuration. Let's start with introduction to Azure Load Balancer. In this, we are going to first focus on how can we create and choose a right load balancing option for us. So we are going to focus on that. Then we'll implement a public load balancer and internal load balancer. As the name suggests, one will be publicly accessible over internet, while the other one is for the internal configuration with the within virtual network kind of a configuration. We are going to focus on determining load balancer SKUs which are available as of now, and then we'll create load balancing rules configurations with that. At the end of this, we are going to create it practically, so we'll see that part. This slide is very important because it is actually showing you multiple options which are available in Azure Cloud for load balancing solutions. As you can see, basically we have four options: application gateway, front door, load balancer, and traffic manager. Now obviously there is one question which should come into your mind is, which one is going to be the right choice for your requirement? Well, the answer is you have to ask a couple of questions to yourself first. Based on that, you'll get to decide which one is going to be the right choice. For example, if I ask you a question like, does your application use HTTP or HTTPS, or is just something which is based on other protocols? Or maybe I can ask you, is your application public or internet facing application? Or maybe I can ask you a question, is your application deployed in multiple regions or it is located in one single region? Well, if you have answer of these questions, then it will be easier for you to decide that which one is going to be the right load balancing solution for you. As you can see the slide, we have different comparisons which are available for protocols, for different kind of global deployments. Now you can see that in the global deployment, only front door and traffic managers are actually available. Then if you focus on some kind of a regional deployment, then you have application gateway and load balancers associated with that. Also, you can focus on the environment and security sections. Obviously, I can understand one thing here, that when we talk about environment which are focusing on Azure as well as on-premise kind of a structure is also there, then maybe I can go for application gateway and front door services. But if I'm focusing only on Azure kind of a thing, then I can go with the traditional load balancer. Notice one thing, the load balancer which we are mentioning here is a Microsoft load balancer, which is a layer 4 load balancer. But that's why it is not going to work on HTTP, it's going to work on TCP and UDP. While the application gateway and front doors are actually a global load balancers which are available on layer 7 load balancing kind of a configuration. And that's why it can work with HTTP, HTTPS and HTTP2 as well. Now obviously, in this particular configuration, in this one single slide, you will not be able to understand the differences between these things. And that's the reason I have one more link for you which is going to help you. If you see this link, this is an official documentation which is available on learn.microsoft.com. You can just note down this URL, and in this URL we have this thing which is known as decision tree. Now the title of this page is like load balancing options which are available on Azure. But instead of going through all the reading configuration there, this decision tree is actually going to give you a better understanding of which load balancing solution will be right choice for your project requirement. You can see right now the same question which I asked you earlier is actually mentioned here. Whether this is HTTP or HTTPS based application, whether it's an internet facing application or not, is it deployed globally or a particular region? Now when you have answer of these questions, it will be easier for you to choose whether you will go for the load balancer or traffic manager plus load balancer, or maybe you're going to use front door with a combination of application gateway or load balancers with that. Now it also depends on what kind of a service you're using. Like sometimes you need a special requirement like SSL offloading or application layer processing kind of a thing, then you're going to go with front door in that kind of a cases. So these are the options, or these are the decision tree related configurations which are available here, which are actually going to help you to decide which load balancing solution is going to be the right choice for you. Now let's go back and understand each one of them a little bit with more depth. Now let's understand first one with public load balancer. Obviously, as the name suggests, it's going to map public IP addresses and port numbers of incoming traffic to the virtual machine's private IP addresses and port numbers, and vice versa. As you can see here, the first point is showing you that we have some cloud-specific TCP port which is open associated with that. It's going to be coming an incoming traffic which is coming from the internet, and then it's going to do a public load balancing distribution to maybe multiple virtual machines. Obviously, this kind of virtual machines are going to be your web layer kind of a virtual machines. Basically, these virtual machines will have your web applications deployed inside that. This is going to apply load balancing rules to distribute traffic across multiple virtual machines which are available on that. On the other hand, if we talk about internal load balancers, then as we can see here, internal load balancers are going to distribute traffic only to the resources inside a virtual network, or that is using a VPN to access Azure infrastructure. As you can see in this diagram, it's showing you that there are virtual machines which is connected with this internal load balancer, and the internal load balancer is actually distributing traffic to another 3 SQL database kind of a database tier. Now obviously this is a scenario where internal load balancer is going to be useful, because obviously I do not want to expose my database tier publicly to any internet providers. Now that's the reason this 1433 kind of a port is also mentioned, which is the default port for SQL Server, and using that we are actually going to associate with this. Remember, in this case, your front-end IP addresses and your virtual networks are never directly exposed on the internet endpoint. And when you're going to enable load balancing within virtual network to a cross-premise kind of a virtual networks for a multi-tier application, or maybe for a line of business kind of an application, you can use this kind of an internal load balancer with that. Also, when you're using load balancer, another important thing which we have to keep in mind is we have different kind of SKUs which are available. Now, as you can see here in this slide, we are comparing basic and standard kind of an SKU. But for your kind of information, very soon the basic SKU is going to be deprecated, and that's the reason you have to focus on standard SKU. But still, as a part of this course, we have basic and standard configurations which are available. As you can see, the limitations are there with basic, like it is not available with the availability zones. It's only going to be allowing you to configure 300 IP configurations with single availability set kind of a thing. While on the other hand, standard is actually giving you up to 5,000 instances with even zone redundant and zonal front-end inbound outbound traffic associations with that. Also, basic SKU is not giving you a service level agreement for the high availability. With the load balancer without high availability is something which is not going to be a very important thing. And that's the reason we are focusing on standard one, which is giving you 99.99, basically 49 kind of an availability is going to be guaranteedly available with the service level agreement of standard SKU. Basic SKU is always going to be open to internet by default, while in standard SKU, you can make it more secure and you can actually configure the inbound connections with the help of NSG configurations with that. Now, these differences are basically giving you a clear choice, which is going to be a standard SKU when you're going to use it for your testing purpose or a production purpose. Now, this slide is actually talking about a load balancing configuration for the internal traffic to the virtual machines. As you can see in this diagram, left side, we have a client computer. Basically, this is that computer which is going to be used by your end users. Then you have a front-end IP address, which is going to be direct point of access for end users. And then whenever you're going to hit that front-end IP address, is actually going to execute the load balancing configurations based on the load balancing rules which you have configured inside that. Now, when we are going to do the configuration practically with the help of labs, we are going to configure a load balancer configuration in which we are going to create a rules for the load balancing configuration. And these rules can be combined with the net rules also. So when you are dealing with network address translation kind of a rules, that can be combined with that also. Obviously, based on that, you're going to have multiple virtual machines through which you want to do the load balancing configurations at the end of this. Also, they are specifying here that a net rule is explicitly attached to a virtual machine or a network interface associated with that to complete the path to the targeted computer. So basically, when you're configuring that thing, you are going to provide only a front-end IP address to your end users, and based on that, they will be just hitting that. All other things like load balancer configuration is going to be taken care with network address translation configuration with your backend virtual machine pool. So basically, there will be something called a backend pool configuration in which you're going to provide all this configuration for multiple virtual machine backends. We are going to see this thing practically in the lab, so I think at that time you'll be able to understand this thing in a much better way. As I said, demonstration we are not going to focus right now, but we are going to focus on the lab. So I request you to go through the next video, which is going to be a lab of this particular module. Hey guys, sorry for interruption. My name is Maruti and I'm here to make a very important announcement. I hope you are liking our videos and you're doing a continuous learning with us on an Azure Cloud and AI related topics. If you are enjoying this thing, I'm going to announce SkillTech.club, which is our upcoming website, which is going to be launched very soon. We are here to tell you one thing, that everyone who is a subscriber of this particular channel will get Azure Cloud and Azure AI related certification courses free of cost in SkillTech.club. So you will be a part of the SkillTech.club kind of a membership automatically free of cost. And everyone who's a subscriber of this particular channel will get those benefits which are available in that. So what are you waiting for? I request you to please subscribe to this channel and share it with your friends and families if they are also interested in Azure Cloud and AI learning. That's it from my side. Now you can carry on with your learning. Thank you. With that, let's start with our next thing, which is Introduction to Azure Application Gateway. Now, as I said, most of the time people get confused between Application Gateway and Load Balancer. So before you proceed to this, I suggest you to understand Load Balancer properly. And I already told you one biggest difference, that load balancers are layer 4 load balancers, while Application Gateway is actually layer 7 load balancer. So this is the one which works with HTTP, HTTPS and all. This is basically focusing on application. That's the reason the name is Application Gateway. It's going to determine Application Gateway routing. We are going to see that thing. We'll also focus on configuring an application gateway, and we're going to set up different application gateway components. If you want to do that thing, same like load balancer, you need to understand this configuration. In this case, left side, you do not have a client computer, you actually have a browser, because it's going to be an application which can be accessed by anyone through that browser. Once you have that browser configuration, it's going to hit the application gateway IP address or a fully qualified configuration of the DNS associated with that, and then it's going to associate with HTTP and HTTPS listeners. This is a point where your traffic routing is going to happen. So this is going to manage the web request, is going to route the traffic to the pool of a web servers which are based on the URL of the request. So you're maybe going to have multiple things at the right side. Maybe it's just a virtual machine, or maybe it's a scalable virtual machine using virtual machine scale set, or maybe you have some kind of an on-premise servers which are available on that. Any of these things can be added as a backend pool configuration, and then based on the rules which you're configuring inside this is actually going to do the load distribution. You can configure multiple things based on the weightage, based on the routing, based on the parameters. You can configure the routing patterns, and you can distribute the traffic into your pool specific deployments which you have done inside that. Now, as I said, there are multiple configurations which are possible with the rules and routing. You can see right now we are focusing on two different configurations. We have path-based routing and we have multiple site routing kind of a configuration. As the name suggests, in the path-based routing, you're actually going to pass on some kind of a parameterized content in the path. Now, as you can see in the left side image here, it's actually showing you that you're going to hit the base URL like contoso.com. Then the application gateway, which is actually associated with the web application firewall, is going to be checking those things based on the rules. Now, if you have some particular patterns which are given into that URL route, like /images or /video kind of a thing, then based on that path is actually going to be navigate to a specific pool of the servers. Maybe I want to get images kind of a content from these virtual machines, and maybe I want to get video kind of a content from the other virtual machines. This path-based routing is something which is very similar to your content-based routing configurations, but you provide the path in the route, and based on that, it's going to be navigating to a specific group of virtual machines available in the separate pools. On the other hand, if you try to do multiple site routing kind of a thing, this is like you're not going to use application gateway only for one application. It is actually going to be focusing on multiple websites. So you can see right now, the user is actually going to hit the application gateway qualified domain. So maybe you're going to have FQDN, fully qualified domain name associated with this, or the application gateway IP address is what you're going to hit. Based on that is maybe going to navigate to one website or the other website. In this case, each pool is actually dedicatedly hosting one particular website. Like maybe I have one website called contoso.com, which is hosted in the first pool, and the fabricam.com, which is hosted in the separate pool. Obviously, in the complex or big applications, we are going to go with path-based routing, where we can actually distribute the deployments in multiple servers and then in small applications which are maybe connected to each other, and maybe you have two different applications which are providing different kind of sister companies of a same organization, then maybe in that kind of cases you're going to have separate pools configuration for the separate website. You can do both kind of configurations in the routing. Whether you want to go with path-based routing or a multiple site routing is something which is totally based on your requirement. Okay, now let's have a look at Introduction to Network Watcher. In this module, we are first going to start with understanding what kind of a network watcher features are available in that and what is exactly that. Then we are going to review certain things like IP flow verifying diagnostics. Then we are going to review the next hop diagnostics, and then we are going to visualize the network topology kind of a configuration. Now, all these are different features which are provided by Network Watcher. Let's start with this. Network Watcher is one of the coolest service of Microsoft Azure Cloud, in which, as the name suggests, is going to help you to keep a watch on your network related traffic associations. Now, when you're dealing with this thing, Network Watcher is actually by default getting provision whenever you're going to create any virtual machine or virtual network kind of a services in a specific Azure region. When you go with the Azure Network Watcher, it's a regional service with various network diagnostics associated with that. As you can see in this slide, you can do connection monitoring. You can also focus on the topology of your network. You can take care of the IP flow logs. So you can actually verify, diagnose, and connectivity issues associated with your network. You can try to focus on next hop, which is going to determine if the traffic is being correctly routed to the monitoring tools or not. You can also focus on the flow log maps, IP traffic through a network security group associations with that. You can do the troubleshooting with your connectivity, and it's going to show you what kind of an issues are associated with your connectivity. And then based on that, you can actually configure the connectivity between your source virtual machine and what kind of a different topologies which you want to associate in the destinations with that. Basically, this is going to help you with end-to-end connectivity issues and troubleshooting solution services with that. This screenshot is actually showing you that how we can configure the IP flow verifying the diagnostic associations with that. As you can see in this particular slide, we can check if a packet is allowed or denied to and from a virtual machine. So you can actually provide a local IP address configurations with that. You can choose your packet details, like what kind of a protocol it is using, what kind of a direction you're associating with that. And when you click on the check button, it's basically going to show you whether this is accessed, denied, or it is actually allowed with that. This is basically the same thing which you have tried and used earlier with the command line when you fire a command called ping. So when you do the ping, it's actually going to check the connections with that. This is trying to do the same kind of an activity visually in the portal UI. Now this screenshot is showing you similar kind of thing, which is for the next hop diagnostics. This is going to help you with determining whether the traffic is being directed to the intended destination by showing the next hop. You can see in this configuration right now, we have our subscription, we have our resource group selected. We're also selecting our virtual machine, in which maybe virtual machine number 1 is actually selected with the network interface card. After this, when you click on the next hop kind of a button, it's going to take the source IP address, it's going to focus on the destination IP address, and it's going to give you whether this is reachable or not. Now, this is also something which is very similar to the command line command which you have used, which is known as trace route. Now, if you have tried a trace route kind of a command, this is exactly doing same kind of a thing on Azure portal. Next, and the important thing is known as topology of your Azure Virtual Network. This is going to be a very important feature when you have a complex configuration done on your virtual network. It's going to provide a visual representation of your network elements. It's also going to show you how this traffic flows are connected, and this is basically a map. So same like you're using a Google map or any other map, you can actually click on a particular object, you can zoom in into that, and you can get more details about that thing. It's actually going to give you a view with all the resources in a virtual network. It's going to provide an associations also, relationship between the resources, and it is something which you can locate the Network Watcher instance in the same region as the virtual network associated with that. With all this configuration of our network traffic keeping in mind, let's get started with our lab in the next video, in which we are going to implement the traffic management with all the services which we have discussed in this module.